button. So we need the chat window and we need the attendee window. Good. So let's simply try it out. It's running. Yes. So I'll quickly minimize the last project from today morning and let's open our QWT test project. So where was it? Oh, and one thing that is worth mentioning, you might have noticed that there is an entry in the Moodle for last week. I completely missed it. That was Rector's Day, so I'm sorry about that. Obviously, any homework deadline or alike is extended by 1 more week, and not being there, of course, is completely fine. But of course, you can watch the YouTube video if you like. It's insightful. I show some things about using network sockets and interpersonal communication. So a subject we might return to later. But for now, we wanted to play with the user interface. So we open the QWT test UI and make some more room. So this is how it looks. We have our start button. So we want to add a plus button. So, oops, do you want to grab this? Ctrl Z. Ctrl Z doesn't work. But then it will be smaller. I wanted to move this bigger here. Right. So the way we add the button is just we select here either a push button or a pull button. The main difference is that push buttons have a certain minimum width while tool buttons do not. And another difference is that with a tool button, you can add a submenu so that we have like these buttons, like this button here. You have a button and then next to it you have a thing that you can click to open more items or like here a bit. Although here like the main button triggers no, it doesn't. You can set in Qt the actual behavior. So if you want the main button to always trigger the menu, or if you want the main button to trigger one default action. It depends on your preference. But here, for simplicity, let's just go. Let's quickly stop it because I made it run. Trying to demo things. You just add a push button, and the simplest way is to just drop it either into an existing empty square, or you can move it somehow and then you see it makes the line, which means that it will add a row or a column. I would say we add maybe here. Oh, I missed. I dropped it a bit too low. Like if you have two, now it's at the right place. If you have two or more layouts, one in the other, then you need to be careful where you are dropping things because it's then easy to drop them into the wrong layout. But it's a purely graphical thing, so you will see if it doesn't work, and you will see, and if it looks good to you, then probably it's fine. So let's say not. We add some text, which is just here the caption, so that the user knows what to click on, and we can specify an internal name, btn add. I like to prefix the controls with like a very short abbreviation of what the control is doing, because sometimes you might want to have like a let's say a edit box, so it would be called text something, and then you want to have a label that describes the edit box. You could just drop a label, put a text, and don't care of it. But if you, for some reason, would want to programmatically change the content of the label, then you would not want it to be called label 124, but you would then call it LBL something, for example, or you would call it cap for caption and then something like that. So there is a lot of freedom in these things. Let's save it and then go to our main application. There is, by the way, a way how you can, to some extent, connect already events from here using this signal slots panel. But I find it more useful to use the UI, to use the code directly. It gives us a more fine-grained control. So here, likewise, with the button start, we go with UI, btn add, comma, reference to one, double point, rest, the intelligence plane. Rest. Okay. This, and then we can specify a lambda function, or as I think I showed earlier, you could also just have a slot which you define on your object here. So maybe for the demonstration purposes, we could do that as well. We'll add here private slots, void on and plot, semicolon, and then we go here, this, and this like a bit a different way of connecting, because instead of using this signal, then brackets, and only the name, and the bracket close, and then in a similar way for the other one, float, open brackets, name, close brackets, and where you also need to in fact specify the right arguments, which is a good opportunity to make a bug and mistype something, because the compiler doesn't check, only the Qt runtime checks it. So then you get like a log line which says, oh yes, this connect or that connect didn't work because the slot wasn't found or the signal wasn't found. But it's not something that would like outright break your program that you notice, okay, I need to fix this right now. This method is here a bit more reliable. So this must add qwt test on. Oh, that was supposed to be capital on. It's not showing it. Let's just copy it. The IntelliSense is not up to date. Then we will just copy and paste things. And of course, we need to create the slot. Maybe here, right? Found. This slot import is not great. Plot. And then we can do something in here. So we could add a plot. In our case, we already have this add plot function here, which we invoke somewhere, something. Not turn this off on purpose, or what was the plan behind it? Yes, we changed it to set the raw data directly. So basically, what you would then put into this function would be kind of the content of. We'll do that quite. Point. So we have here our add curve. That's one thing. So basically, from yeah. So basically, from our on add plot, you would just call add curve and then specify some new ID and some new color and some new description. So let's do that really quick. So ID, I think that is for random, so let's call it -1. Color, we need the color. Qt color red. Red is nice. And style Qt solid. Qt solid. And comma. Here we call it just edit plot. Edit plot. Right here. That adds the plot, but we don't have any data for it. So like how little data do we have for that? What's the button? The first word to add values of okay, I see. So what we want is to improve the thing that in the UI here we add another line like this. So there are in principle two ways how this can be achieved. One is the manual way, let's say. So one way that can be done is that we just add all those elements individually, And the other option would be to put all of those elements. I don't think we use them. Yeah, they are just for demo purposes. Here, they don't do anything. So let's go with the second option because it's kind of, if you want to reuse it, it is more reusable. There's also like a third option where you would create a new widget, complete like a whole class, and here a new UI file, and then just put things in the UI file. But I think this is too much work just for these few controls. So we'll use the option where we create a widget from scratch here and then just insert it. So we start here with widget, widget equals new widget. Then we need to I wanted to write grid layout, but let's be honest, this thing is just one line. So let's go with the horizontal layout. That simplifies things. Do I need to include that? Include that. Box layout. And we can include the box layout for horizontal layout. Where are we here? No, that's not good. I don't trust this. One moment, please. Either our intelligence is not good, or I don't remember what to include. Of course. It's called HBox layout. It has the full name is already an abbreviation. No HBox. Yes, it should be according to the documentation. No HBox layout, yeah. Layout with new layout. We can either set the layout on the widget, or we can just specify the widget as parent, and then it will automatically set it. And now, just to demonstrate the proof of principle before we completely add everything, and new to label. Oops. Yes. And now we need to insert it. And to insert it, we need to know where to insert it. How we do it best. So we know we want to insert it at row column 0, and we would want to insert it naturally at the column, sorry, at the row of the button, such that the button is pushed down by one row. So can we find out where that is? I'm not sure. We could just have like a variable which we initialize with a manually selected offset for this, and then just shift down each time we add something. But let's see if we can find out where to insert it. But first, just as a proof of concept, I will just insert it manually at 0, 1, 2, 3. At 0, 3. So, right, I think we need our main layout. We need to be able to address our main layout. Can we do that? It has the name grid layout. Okay, that is easy enough. The next one will be grid layout 1, which will already be ugly. So, grid layout actually is a grid layout 2 for whatever reason. Let's say project. Let's say, okay, let's just add then specify. I was thinking there is an insert option, because if we just add, then it will kind of overwrite what is there. We want to do it differently. I mean, we could always add it at the lower line, so we can go with that. So we said, for the widget, oops, typo. We go to actions, capitalization. So we said row 3, column 0. Now we get a thing like row and column span. So row span is 1, but the column span, so how many columns or rows it takes. We want one very long, so 1, 2, 3, 4, 5. Let's go with 5 or 6. Let's go with 6. Then we will do the whole thing. 6. Right, so now when we press the button, it should add it or insert. It doesn't insert, it just adds it there. And how we do then the inserting, we have to see. So, each time we press it, it adds one here, but as said, it does not advance the button one row down. I forgot there was an insert function. I think the other ones would have the ability to just like an insert. That means at widget, and that will not work as we want. So, I mean, we could just for simplicity say that we just add them further down. So let's first remove all of those things. Now we remove them later. We could just add it that it adds it below the button. That's the easiest way. So I think we'll just go with that. So the proper fix would probably be to really know which elements are below and then shift all of them by one for you insert the other thing. We can try this probably later, but for now let's go the easy way. And the row count is 0 because at the beginning we don't have any. So here we make row count plus. So it will increment our row count each time we add something. Of course, if we would like add a remove button, which we probably should, then we would need to decrease this counter so that the next insert again happens again at offset. Yeah, exactly. A variable like Stefan already suggested. That's what I have implemented here. And now each time it adds until we run out of screen real estate. I'm a bit surprised why it's so high, but that will probably be because we have not yet specified any content margin. Also, a small note, while we're inserting here the widget, we could in principle create just a layout and insert the layout direct. So there is a add layout function which behaves the same way. It's in the new Qt versions available, and it's kind of probably more handy because you need a line less. But let's stick with this approach. So now for our layout, we're first going to set content margins to all zeros. And 0, 0, 0. It will make the whole thing take less room. Also, I'm thinking management type. Management type. So we have I couldn't imagine. Then let's add all the elements that we actually want to have. So call them this. And we will add a vertical scroll bar next. There is such a thing. It's called a scroll area. Yeah, scroll area. It's even available here as a container. So it's quite easy to install. Well, yes, but this doesn't really help us since we don't know how much. But I can normalize this and then not this one. So instead of test, we want to add. Maybe we'll stick with a label and to section. Test test percent fun is a nice feature of Q strings. There needs to be a string that you can specify percent and then a number, and then it will replace that value with whatever you specify in the argument, and you can have another arg and another one and another one and another one, and for each arg it encounters, it will take the numerically lowest percent number and replace that one, keep the other ones, give it a new string, and then repeat it ad infinitum until you have replaced all of the percent something with arguments. And if you run out of argument calls, then at some point you will just have the percent something standing there without having been replaced. It is a bit of a wasteful approach, to be honest, but I would very strongly assume that Qt would internally have some optimizations to not create the same string 10 times over, but I haven't checked it, so I might be wrong here. So we have our caption, which we just add here, to the label, and then we can add as many other components as we want. And I will always add them with 2 lines, because we usually would, although not all of them. For the caption, it is after everything here, but doesn't matter. First, let's put over the combo box. Then the idea to not do one-liners like I did initially is that it allows you to then call some functions on your new object, and like in the case of the combo box, you would want to add some items. So here, let's add you can either use add item to add one item to the combo box, or you can use add items to add a string list of items. And it's actually quite nice because you can use a string, write all the captions, so let's say sign, and then let's say choose a separator. Let's go with a vertical bar, sign, tiny, lot of that. And then we have the split function on our string, which takes the separator and spits out a string list, which then can be consumed by our combo box, and we instantly get the combo box populated with a one-liner. And usually it's quite reasonable to just have everything one line. If you would want to have other options which then decide which of the options you show, then you would do it with a single lines, but for now it's fine. So then we need the label. So now label. This one will be one line because it will always just say frequency. Then copy this because we need this data on for amplitude. You don't need to track where you're inserting them if you have a horizontal or a vertical layout. You just add, and it works perfectly nice. These layouts should have the insert widget option, which is much more handy. So unfortunately, it appears the grid layout does not have that. So we might need to either change the layout in our plot or create a bit more complicated. So Q8 Anything about frequency. Frequency is an abbreviation for the variable name. Continue. As you see, I like to use a lot of copy and paste, because then you can code faster. Although the downside is that you are much more prone to make some copy and paste mistakes. So there is no free lunch, as the people on the YouTube are saying. Always playing with something. So we didn't want any additional things. This space here we will let out for now. So it's now quickly reload it, and we should be able to add a nice new lines, and then we can jump directly actually to the scroll area, because then we don't need to care to handle the missing insert function our grid layout, and the scroll area works slightly differently. So as you see now, it is already much better. And at this point, I would also now, for simplicity, quickly let's test this and open in module. And let's remove the tiny sphere, because we don't need them anymore. Start. And that's how it behaves. So the last element was constraining the height, and it was setting like that. This height is the maximum height, so nothing should have a higher height. But if we put the button here, it will constrain it again. If the button height is a constraint, so this is good. And now we need our scroll area. Oops. I'm working here on my laptop with a very high resolution screen, so you see much more of the text than I do. I need to really mention my eyes here today. This is still clear. And we will insert it in SAC. Yeah, good enough. It's by default called from the scroll area, which is fine, I would say. You can leave it like this. As said, as long as it's just one of the type, then it's okay. It only gets messy if you have to. And I don't like things like scroll area 1, scroll area 2, scroll area 25, because then you kind of lose track which scroll area does what, and this is not good. So it's usually good if you want to address anything from the code inside your Qt Designer created UI, to give it a proper unique name which is easy to remember and not require any manual level of recollection to use. Scroll area. How did that work? Let me remember. Set layers, I think. Yeah. So we will. It should have a layer by default. If it's created by the designer, it should have a. It might be. Let's just grab the layer and see if it's null or not. If it's not null, if it's not null, then we need to set one. And if it is null, if it is null, then we need to set it. If it's not null, then we can leave it. But I think it will be null. I'm pretty sure that I will get a code on that. Kind of an inside joke in our group that we get buttons of code on things, even though I stopped using code some time ago because it's one healthy. Yeah. Button. And it's null. So we need to set it. We could do that from the UI thingy, but I think since we want to work with it, it really is more convenient to actually add it here. So to now we know how to write the code box there. We'll call it scroll layout. We want to do this with our scroll again, the whole line. And as you might see from here, if we look on the layout, then the vertical box layout is like individual lines on top of each other. So we just always add a new one and a new one and a new one. Also, I think we can change the style of the scroll area to not look like a recessed thing, but to like fit like a normal element, so that ideally you don't see the scroll bar if you don't read it. It's minor cosmetic details. we are not so picky, so that we realize fix data. So yeah, area and yeah, some of the intelligence is a pretty broken. I think in the moment where it displays the tooltip, if I press exactly in that moment, it then does as in the line instead of actually as it should insert whatever it is highlighting as the default recommended option. So we have our layer as we want. We just click add widget, so we don't even need to count rows. That is such an improvement. So I mean, you can still row count here to just display it as a portion of the text. So I will create this with plus row count, then it will increment instantly. So the first line will be called the line 1, even though its initial is 0. And the breakpoint, and let's run it. Oh, I guess we need to set a minimum height for our widget because it tries to fit it in this corner as long as it can. And this does not work the way we want. So widget set minimum height. I don't know, 23 and 32. Let's try 32. 22 is like the standard icon size on Windows, like on the they changed so much. In the old start menu, if you had the put set icons, that was the size. If you have the icons in the taskbar, by default it's also usually 32 size. That's scrolling, yeah, it's not scrolling. What did I forget? You can maybe a scroll bar, but it is as needed, but that is needed. And I can make it, I can make it to be always shown. But I think there is some the configuration which we need to improve for it to work correctly. And I think showing it will not change anything. It's just a desperate. Yeah, it kind of is ignoring the minimum height for some reason. Maybe it's set minimum height. Right, that is set. That should be respected. One moment, please. I actually have a code center somewhere which does exactly that. I just I just need to connect to it. Moment, please. I need to connect to a VPN so I can access that first. Let's take catch 22 with all the super large with all these super large frameworks, that it is easy to forget details of some functions which one is not using all the time. Yes, so now this is starting. And so we have this car area, and then we place it in non-default parameters in there. No, we can include an everything. And next step, it is widget resizes the this is changed. Let's try it. And let it here. Oh, but this is checked, so this is fine. Let's see what else might be working. Right. Ah, okay. We don't want to set the layout of the thing, we want to set the thing, give the thing a widget. Yes. Here is core with 2 L's, probably. Yes, so the other one has a wrong name. Let's quickly fix that. And as well. Here core level, and here double L, and then this is to be changed anyways. And back. And instead of this, we do widget will be the point of layout. And at this point, that should all the linkage be all the linkage we need. I have in my code also explicitly said widget resizing dot show, but since it's already set in the design, I don't think this is necessary to set it again, and I don't think it would someone code reset. So stop. Yeah, and it's working. We'll almost have a huge spacing that is not part of it. So to fix that, so easiest thing to do is of course to just set the right item separation from our layout. The content margins actually both. Content margins to 0, 0, 0. That will increase our separation, but we also make it with nicer. And now that's missing. No? 0 might be not enough. 0 may be to 0. Content margins. Private component. Probably it only has like one content margin or two rather. Because it is oh, I didn't set. That's fine. I was thinking because it only has like one row, it might not have margins for both sides, but kind of probably is the wrong assumption because everything has margins. So add one, and two. Well, that looks nice. Actually, content margin is 0. But it is kind of stretching it to however much space it has, and only when it runs out of space it is doing it. So we could add a spacer in the bottom, but that spacer might have the effect that then it will always show the scroll bar, which we don't want to. So this again to calculate the values inside. The pity that it doesn't auto save from the designer. Now when you have the frame itself can also be disabled somewhere, and then once run out of space it ends the scroll bar. So in principle, what could we improve? We could move the button here maybe, and it would be different. We keep the button like this, like this, and here. And we insert in that space again. And kind of a unused row which is there is unfortunately no easy way to remove unused row, so you kind of have to insert something and delete it. There is no easy way, so there are some limitations to how this thing works. Now we have a button here, so we can out it there. Let's see if we can change the style so that it doesn't show the border style. Something policy, font, focus place, content quality, thinking, and drag and put method frame shape. Sunken plane, quality height, height. So let's reset this. No frame, that helps. So I didn't save. Not great. Save. Right. And now it should be quite nice. Then we have our some room at the bottom. Then we can add plots. We're just missing the spacer. Let's try adding the spacer because it would make it even nicer. Also, one problem, if we change the length here, it's not all nicely aligned. So we might want to redesign our system, but I think for now it's fine the way it is. How is this thing called? Vertical spacer. So let's make another vertical space. Okay, so apparently the answer is good enough. That, then let's not waste time with playing around with spacers. The idea basically would be that you would add a spacer like the vertical one, which is set to take as much room as it can, but not say it has a minimum height, so it should not trigger the scroll bars to appear, and then everything should be aligned at the top inside the scroll area. And that's it. So, right here. So what I actually wanted to talk about today, and I think we haven't talked about it yet, are container types. Container types are container types are usually templates which allow you to somehow contain other types in them. So for example, a simple example of a container would be a list. And the idea is that you have your list container template, and then you can instantiate individual implementations for whichever type you might want. So it's very flexible in its design and very user friendly. And more complex examples are, for example, maps that we will take a look on, but now let's create a new project for that. I will go with a Qt console application because I can show both STL and Qt in one project. There is no point in splitting it. Audio quality. I can try to do something about that. Maybe with the headphones, it will be better. I can go to somewhere. Let's see. Headphones. Lautsprecher. Microphone. Kopfhörer. Hi. Right? Test. Is it better now? Or don't you hear me at all? Test. 1, 2, 3. Test. Much clearer. Okay. Then I just need to find out how to change this in for the recording. I will stop the recording and restart it with the other device, since we are just in the process of starting something. Okay. Good. So let's continue. Right. So we will create a new project which is called container test, and there we will compare and demonstrate the different container types available in STL and Qt. They are quite analogous to each other, so the Qt ones are very much inspired by the STL ones. But I think like they might have started off with something very own, and at some point they decided, oh, we should make it as comparable as possible. So let's first include something. So the first most simple container-like type you already know is a STL string, because it's basically just a container for characters. So std star equals 1, 2, 3, 4. But so the next slightly more advanced container type, I shouldn't say, I will not rank them like really in advanced, because there are quite a few which are very comparable, is a vector. So the vector container type is almost like a string, but without special functions, and it needs a type. So you need to specify what you want to contain here, and let's contain characters. Oops. Char. My vect. I'm afraid this will not work. There's already one advantage of a string in comparison to a vector, is that it has special constructors for feeding it null-terminated strings. So here, if we want to give it the same content, we will need to use the pushback operation and feed individual characters. So obviously it is absolutely in no way intended for characters or string manipulation. It's just that I wanted to show something that is somehow similar. The vector has also a push. As you see here, there is no push front, so we only can add elements from one side, which by the nature of the vector is very desirable, because the way the vector stores the data in memory is very much similar to how the string does it, namely that you can have a you can access myVect data, and this thing will effectively give you, okay, let's add a termination 0 as well, because otherwise we'll have a problem. It will in fact give you a C string in this particular example. Const char stern my data, and now if we put a breakpoint here and run it, where is the run button? F5 here. Again. Is it not saved? Apparently it's not saved. Okay, but it is saved. Let's see. Maybe there's something with the hotkeys on the laptop that the F5. We broke Visual Studio. Sorry about that. I will copy everything. So the question is, how does the vector manages its memory internally? Since it stores everything in one consecutive memory area, which is what I wanted to demonstrate next, it will not allocate new pieces of memory each time you add something. It might, but then it would mean that it will kind of make a new block which is one item bigger than the old one, and then copy everything and add the one. So usually the way it works is when it sees that you are adding elements, it will allocate a bigger block, add the elements as long as it can, and when then it runs out of space, then it will again allocate a much bigger block, copy everything in one go, and then add individual elements and so on to this memory. So this is quite useful, because as said, you can use it for string buffers and things. I will just here okay, I will not save. I will just restart Visual Studio, because somehow we managed to break it very thoroughly. I have no idea how that happened. We can close this as well. something is important to close the other things, but might be important to just restart the whole thing. Let's first see if we can save. Now it works fine. Hash include. I did not have such this particular failure mode before. That's exciting. And now if we run it, we will see that the variable mdata, which just receives a pointer, when we look in our memory monitor, it will show us that it actually contains a normal C string with no terminating character and whatnot. So we can open it. So we go to debug, Windows memory, we open memory 1. Or was it there all the time? And I just watched the wrong panel. And we need to kind of breakpoint was one line too low, so we didn't trigger it. So let's rerun it. Now we are in our breakpoint, so we go to mdata, and you see in memory we have 1, 2, 3, 4. Then we have the null, and then we have some markers that indicate that this is not a valid memory after it. So now if we repeat that, so let's keep this variable actually for demo purposes. We can remove one, I think. How was it? Pop back, I guess. Pop back, yes. This will remove the terminating null, and now we will add some more letters. So 4, 5, 6, 7, 8. Let's go with 2 more. 9 and 0, and then we need another 0 like the real 0. So the number 0 is not 0 numerically. The number 0 is, I don't remember, 40 something probably. Right here. So and now we get this block again, and what we probably should see is that the first memory, I need to change the name. The first memory will become invalid as it reallocates it, or maybe it will call actually reallocate and be able to obtain a larger block, but we will see. Oh, that was not what I wanted. I wanted to put the breakpoint first here, because of course no, actually that would be fine. We could still have looked there what's there, but it's necessary if we step through the thing. So we have our thingy, then we go step. We have removed one element. It did not change anything in memory here because it's somewhere else just decremented a counter. Now it replaced the 0 with the 5. It added the 6, and I think the next one, yep, and the next one, it didn't have room for the next one. So this whole memory region got freed. The debug build of the memory of the heap in Windows will fill it with the dd, well, with these, however many these you need, to indicate deletion. And the nice thing about this is that this way you see if some block is no longer valid. And now if we step through everything and then get a new pointer, there might have been actually some in between value. I don't know what's the default growth size. Actually, I think we can change it, but here we have now a new memory region where we again have our kind of ANSI string, and based on this you see this CD that's like created and not yet initialized, and this FD is like an additional amount of space that is allocated, and then in principle when you free this area, the debug heap expects these values to remain unchanged. If they get changed, then the heap can throw an exception saying that you have apparently exceeded the allocated amount of memory, and if that would be a release build, you would already now be overwriting someone else's code or data. Yes, so that's that. And the next element, which is well, the next container type, which is interesting to see, is a list, little l. And a list is different to a vector in as far as that it does not use consecutive memory. So while the vector is quite useful if you need to feed some pointer to something, to some low-level API function which just takes a normal C array with a counter as a second argument. You put your elements all into a vector and then just get the data from the vector and you are set. But if you cannot do the same thing with a list. The advantage of a list is so first of all, how do lists work in comparison to arrays? Usually lists are either singly or doubly linked, so basically you have like a pointer that points on the first element, and then the first element points on the second element, the second on the third, and so on. And doubly linked means that you have like the second element is also a back point on the first, and you have two initial pointers, one to the top and one to the bottom of the list. The advantage of such a memorial arrangement is that you don't need to kind of reallocate a large block of memory and copy everything. The downside is that you don't have consecutive memory regions, that you are using more memory because you need for this housekeeping what points to what. And the third downside is that you can normally not address an element in a list by its offset. You can only do it in a vector with the square bracket operator like with an array. But with a list, if you only have a list and you want to go somewhere, then you need to start at the beginning and then advance through the list and count how far you are to know which element you want. I see there is a question. The pushback is not like code without or just not an interface. The pushback, if we look onto it, goes to a function that does something more, and then does even more. So the whole STL library, it's not implemented like in apparently Python or also C# where you have a large set of kind of interfaces which you can use, and then in the background the framework, the compiler's runtimes would then replace that with its own implementation and do whatever internally is implemented in some other language. But here really these are just all template classes, so you can modify any aspect of its behavior. You can just go to the definitions, copy it, make your own myvector and change anything. Then it of course would no longer be compatible with a normal vector or a normal other container, but it would be quite interesting to do. Also, there are very rare use cases where you actually do such things, but that's outside of the scope of this lecture, I think. So let's come back to the lists. So let's do a list, std list. Well, let's don't do it a list of chars, let's make it a list of numbers. List int my list stack pushback 1, and as you can see now we have the option push front, because since we only update individual references, we can easily add from both sides. And of course, depending on what you are doing, this might be quite useful. And the way all the container types are implemented in SCL, which we'll take a look on next, is such that you actually don't have, let's maybe push 0 in the front, that you don't have, let's say, the need to, it doesn't make it inefficient to work with lists if you are doing it the right way. Let's say it like this. So for a vector, as I mentioned, you can just go for size t, e is equal 0, e is less than, oops, that's 0, my vect size, I plus plus, and then we can printf, yeah, we have printf, %c, comma, my vector, so my vector square brackets I. So it basically behaves like an array. With the list, as said, the square bracket operator is not available. So what we are using to go through the list are iterators let's do it the right way. std list type char iterator e is equals my list punct begin. So usually what you would do in modern code, you would not bother with this, you would just write auto. Voila. much more readable. Then you make I is not equals my list. Oops, there is punct end. Oops, I dropped the y. My list punct end, comma plus plus I. So whether you do I plus plus or plus plus I is in theory not important, but kind of the plus plus I is more optimized, especially if you are really working with more complex objects. And the iterator itself, it is not a machine type, it is not something trivial like an integer or a character, but it is a whole object of its own. Actually, maybe I should have not deleted it. Let's quickly copy this. And let's take a look how such an iterator. And why is it complaining? List. Oh yeah, it was iterator from int. Let's see the iterator. Well, it's this iterator, which is a whole object with many things. And especially important are these plus plus operators, or minus minus, because what they allow you to do is to advance the iterator one way or another. So you can go through the list up or go through the list, so forwards or backwards, whatever you want. And there are some limitations. For example, the end iterator, I don't think you can call minus minus on it. We will need to test it. Usually, if you actually want to go through the other way through the through the list, there is an explicit reverse iterator. And there is the rbegin and rend functions, which give you like an iterator which you advance by plus plussing, but then you are going the other way through the list. And for example, a map, I think, would not have a reverse iterator. You would have to check that, although it might. The implementation of a map would not prohibit you from doing so. It's sorted, so it should work both ways. Probably they added it. Yeah. And the interesting thing is that this iterators, this called mechanism to move in both directions, is implemented on every STL container. So I think you can even do it on string, although I never tried because why? But it's on vector, on map, and on list, as well as some other types like queue, DQ, and so on. So a queue would be a singly linked list, and a double-ended queue, DQ, is pretty much a list. So I do not think there might be like historic reasons, so they had like two different things, and at some point they then unified it. So, and they kept the old one simply for compatibility. So this is an important thing in C++ that you kind of ideally would want any newer compiler to be able to compile old code with as little to no modifications. And there are some scenarios where you would need to do modifications, but usually it should just work. Plus, what you always also can do is you can click on project settings, and you can change the active. General. Okay, well in this case we can kind of take the recommended standard from the Qt. So the Qt has a variable that tells which standard the Qt headers were compiled, but you see you could in principle select a manually one of the C++ standards, and the compiler would then implement this standard and nothing else. But usually they try to keep compatibility as much as possible. Usually it's rather like certain things have been disabled and then they will not. So when you go to a higher standard, you get new features, and certain existing features will kind of throw you an error or a warning that they have been deprecated because they are unsafe or something like that. So the idea generally at this point really would be that the way it would work is that they would not change like any API that kind of would compile but then work differently. They would usually just want you to, okay, we have a good reason to change it, now change it in your code, or not use the newer version. And one thing also, which is I guess quite important to know when working with iterators, is how would you delete an element. So if we are here, we could in principle want to delete an element at a certain offset, and how this behaves with the vector, it's quite clear. The data behind the element are copied one position upwards, and the length variable is decremented by 1, and that's it. And then basically you would kind of just change the I loop, so that during the next go through you would kind of do the same position again if you deleted the current position. You cannot do such a thing with the list. So here, for example, I inserted the number 9 into this list, and we would, let's say we want to remove it. So I will remove this I here, and let's see. So if and then another point, how do you access the content of your iterator, so the thing it points to? You do it by dereferencing it. So since we have a basic type, we just go asterisk I. So if asterisk I is equals 9, then we want to get rid of this element, but there might be more 9s in our list. So there could be 2 9s. So what we then do, is we want somehow to advance the iterator to the next element, and at the same time remove it from the list. And the thing is that if you modify the list, this can invalidate other iterators. To which extent this happens, it depends on the actual list implementation. But the proper way to delete an element from the list usually is to I is equals erase, and erase takes an iterator or 2 iterators. Like you can erase a range. You can have like an iterator, a first iterator, and then if you have 10 elements, you have an iterator that points to the 5th element, and an and an iterator that points to the 8th element, and then you could delete all of them in one go. And what it returns is usually an iterator to the next element after whatever you have deleted. So if we just go with a simple case, erase I, then I will already be the data for the iterator for the next go through. This is why we didn't want the I here. And of course, then we need an else case. I missed that. Else case where we just do I++. So this way, it will either advance the iterator without changing the list, or it will change the list and give us a new valid iterator pointing to the element which remains now in the place of the element which has been deleted. So if we put a breakpoint here and run, we don't need that. And now in our list we should have only 4 elements and no 9s. As you see, it worked nice. You could do this very same thing with the reverse iterator. It is not it behaves pretty much the same way, and since the iterator as such is derived from like a at some point it's derived from the same, like it's almost the same, it's just a different slightly version. So it internally, we can look on the implementation. Internally it contains the implementation of a normal iterator, but it overrides some functionality. Well, it overrides obviously our operators here and those as well. So this yeah, usually the implementation of STL is something, it's nice maybe to take a look at it, but it's super convoluted, so it's not something one need to bother oneself. So let's now at this point just go to the next very important container type. So like Q and DQ we just ignore because they are boring, and they are pretty much covered by list and vector. So the next one, which is super important, is map, and there will be another one called the multi-map. So the idea with a map is std map. As you see here, it takes already 2, actually it takes more than 2 arguments, but only the first 2 are kind of mandatory. So we can specify, for example, let's say int and std string, my map. And the idea is that you can use the square bracket operator to insert something at a key, something like this. And while with the vector, if you try to use the square bracket operator on a non-existing offset, it will just crash. Here, since it's a map, it does not have like a consecutive memory block inside. It just has, usually in a red-black tree structure, organized all the keys and values. So you can insert any amount of 555 keys and values into your map. And if we run it and quickly look what it contains, it will only contain those two plus maybe a couple empty slots for next insertions. But I think the map should not have this optimization usually. Yeah, it does not. So as you see, we only have these two elements, and we can now, on the any key which is valid, which has a valid value for int, insert something. So we could, for example, go with inserting at position 1. Well, I should not say position at the key 1, and then the nice thing is that it also can be used for overwriting. So we can use overwrite by 1, 1, and then if we run, the map will be containing at position 1, 1, 1. Tack. Here's the mouse, we have now 3 elements, so we added 1, and now it's obviously the newer one. So the old element gets discarded and the new element gets inserted. And the way this operator works is that we can use int reference test, or let's call it my ref, or we could just write auto. Auto is always great, and what it gives us is a reference. Why is it not? Oh, right. The reference must be to the value, not to the key. Std with string reference, my reference, and now we can change the reference. We can change the referenced value, and whatever we do to it, it will reflect directly in the map, which is super useful in certain edge cases. 6, 7, 8, 9. So put a breakpoint here, and then we'll just set through the thing. And the important thing is that this way you make like one lookup operation in the map, which might, depending on the size of the map, have a certain non-negligible computational complexity. So here, if we see, we have now 3 elements and one is just empty. And if we step by 1, then we see in the map we have now 1, 2, 3. If we make another step, we will have in our map 4, 5, 6, and so on. So it always changes the object in the map. One very often used use case where this is useful is when you have an operation where you want to do one thing if you have to insert a new element, and do another thing if you want just to update an element. So you basically just take a reference from your map. At this point you know the element exists in the map, and then you check whether the element as such, for example, if it's a string, then you can check whether it's empty, or if it's a pointer you can check if it's null, or if it's a custom object you can use your custom function to check whether it is in an uninitialized state, and then do your initialization, because this means then to you implicitly that the map just inserted this element. Or if you get already an initialized element out of the map, then you know you can use it directly, or you probably want to update it or something like that. And the next thing which we can use with maps, so a few things to say. First of all, you can remove, let's say we want to remove the entry at key 1. So this is very easy to just use the erase, and the erase is now well overloaded, so it takes different arguments. It does not just take iterators, as we have already seen with the erase as implemented on the list and vector. It also takes the keys direct, so we can just erase one. And this is of course quite a dangerous thing, because now our reference here is completely destroyed. So when we erase it, then this thing is basically a dangling pointer to something that does no longer exist. So if we would try to assign anything to it, we would crash our application. So what would, for example, be more elegant and more like to say it, representative of what actually happens here is to use a pointer. I mean, the thing is the reference and the pointer, they are both the exact same thing inside what the compiled code looks like. It is just a different way to address those things here, such that it kind of gives us an illusion of those things being two different things, but internally it's completely abstracted. And the advantage of using this as a pointer is that you can check. You could check if this thing is null, but the pointer actually will not be set to null. So we could here at this point say we set the pointer to null, then we erase it, and then we know we don't have at least a dangling reference. So if we try to do something, then we would at least just reference the null pointer, which is always invalid by definition, which also means that if we try to access it, we will get a good reproducible crash instead of getting undefined behavior, because we just overrode some random other location in memory. And of course, the other way to use erase is just to put an iterator to it, so you can go through the map, and you can iterate through the map, and then but this time let's just go with auto, and we of course need to fit the map in here, and then you could erase something from it. For example, based on, if you would want to filter a map not for a key, because filtering for a key is easy, you can just retrieve the elements, but if you would want to filter it by value, which is not supported, you would use a loop like this and then find an element and then dispose of it, or find an element and change it, or something, or find an element and return it for other things to be done with it, depending what the user wants. Yeah, so you can iterate through the map, you can add elements this way, and there is also an explicit insert command which you can also use. The insert is not very nice, because unlike in Qt, the insert expects you to pass it a std pair of the same type that your initial key and value, so to be int, comma, std string. So they could have made it just take 2 arguments and be done with it like Qt did, but now they want this pair object, and actually this way is not the recommended way to do it. So you could make it like 1 and 1, 2, 3, but it is a bit simpler if you use a convenience function that they provided, qMakePair. Sorry, just make pair. qMakePair is of course the Qt variant. Make pair, then you at least don't need to specify the type, but you might run in a situation where you add here something and then it cannot implicitly cast, it would need an explicit cast, in which case then it would maybe throw you some sort of type mismatch here. But of course, since we took the exact right types, it is fine. And the thing returns us a std pair of, I don't remember what it. One is a boolean and the other one is an iterator, but I never remember which one is which. Oh, that's the insert. It did not find the shortly remove this for a second and see if we can now find it. Yeah, so the first is the iterator, the second one is a boolean. I didn't want to press that. And the idea that it works is that the iterator points to the element to where the thing has been inserted into the map. Okay. Test. Of course. The second one was the easy one, but the first one is the difficult one, because now we need to copy our map. I mean, we could just use auto again. That's why auto is so great. Iterator. And the way this works is it will give us an iterator that points to the element in the map. So we can later, after this insert, keep altering the element, which is kind of similar to what we do here. But the boolean here gives us a value whether the element was inserted, or whether a new entry was created, or whether an existing element has been replaced, which is sometimes good to know. Yes, what else? Right here. And now the next thing, a multi-map. A normal map can only hold one value for one given key. So if you try to assign or to insert, usually the assign is usually working like that, or using the square bracket operator. It will rather just take always the one element and then do something with it. But if you use the insert command, map, then you will be able to add multiple entries for the same key, which is quite wild if you think about it. I mean, effectively it's like, let's write this here down, std map int std list std string, just better. So it kind of fulfills the same role as if you would make a map of lists and then have the list contain your whatever you have, but it is kind of more convenient in the way that you don't need to manually take care of cleaning up empty lists. So if you would have like a list and map, and then you would want to remove an element, then you would need to find the right list for the key, and then in this list remove the selected element. And this means you might be left with an entry in your map that has no entries of its own, which might not be desirable. So you would need some code which after each removal of an element checks, okay, is this element now empty? If so, then the whole element would need to be removed from the map. But the multi-map kind of takes care of it, and you insert things into it the exact same way as you do the normal map. But just as said, this time you can see. Let's go with 1 is 1, 1 is 1 1, and 1 is 1 1 1. Oops, 1 1 1, and then let's do the same thing for 2. 2 2 2 2 2 2 2 2 2. The breakpoint, so let's run it. And we have 6 elements in our map, and as you see, all of them are here with different keys. So yes, one thing I haven't told you yet is if you would want an iterator to an element by a key, so you would do that actually quite easily. Auto f equals let's go with multimap punct find. It works on map and multimap the exact same way. 1, and for a map, of course, if you go to the iterator at 1, it will just give you the one value at 1. If you do this with a multimap, it will give you, and now I do not remember, either the first value that was inserted with this key or the latest value that was inserted with that key. We can check it. So let's grab the values from our iterator. Int key is equals f, and the way you get things from an iterator is use the arrow operator, and then you access. So the iterator is kind of a pointer on this pair object that was stored in the map. So here it gives you a first, which is the key. It's another thing which Qt makes much better. Instead of doing it this way, it gives you on its iterators a function called key and a function called value, which returns you references to the key and the value, which is kind of much nicer, I would say, because you don't need, okay, that's not an int, std, because you, oops, little b, little w, I mean, because then you don't need to remember like 1 is the key, second is the value. It's kind of confusing when the things are not perfectly labeled, but here now we see, okay, key is obviously 1 because we were looking for 1, this was guaranteed, and value is 1. So now we see, okay, it gives us the first value that was inserted into the list, which kind of makes sense. And now what you, for example, can do if you would want to let's say we want to remove all the entries, all the one-on-ones. So what we can do is, let's quickly comment this out. Oops. Control C, okay, see. We could, at least I do it this way, for auto F, let's write E. Then we go with find. So we want to get the first iterator. And now the go condition. The go condition is I is not equals map, and so this is most important. It must not be the end, because the end is like already the invalid value. There is nothing at the end. The end is past the valid value range. And then the second thing to do is I dot error first. Oh, sorry, I need an end, of course. And I first is equals our key. So let's call it int to arrays. I should have put a spacing there. That's wrong. Into arrays 1 new column. So zack and zack, and here I is equals my map arrays I zack. So what this loop will do is it will actually, I can even no, that's the easiest way, simplest way of writing it. So we start by finding it, then we check, did we even find something, because we might have been looking for 3 or 4 or 5 for something that is not in our map. Then we will terminate instantly. But if it's fine, then we check whether we actually found the right thing, which for the first iteration is guaranteed, but for the other ones it's not. So then we go here to our actually we could have a plus plus here if you don't want to delete, just to iterate through it. So that's of course up to you. But in case we want to erase, so we just erase the current element, advance the iterator to the next element, then we check again our condition. So it might have been the last element in the map, so that would trigger this condition. If it wasn't, then we check whether we advanced past where the value was which we were looking for. And then we terminate without deleting the next element, because the next element would be then already 222, which we would not want to delete in this particular case. And I will just add here a 333. Let's not overcomplicate things. 3 and 5 and 6 and 6. And there, in addition to this nice find function that we have here, there are 2 more functions which can be used on map and multimap, which can be mighty useful. So map lower bound, and there we specify a key value. Let's go with we need a few test cases, so let's go with 4, which we don't have in our map. So auto E1. Then let's go with 3, which we have in our map. And then let's do the same with the other function, upper bound. Oops. And we need to change the numbering in our eyes, of course, for the thing to 2, 3, 4. I'm actually not sure whether it will show us if the iterator is invalid, but it will not show us any valid content, so that will be good enough. So the lower bound here, as you see, gave us 5. So what it does is it kind of gives us the next bigger key that it can find. So it gives 5. Here we used lower bound on 3, and it just gave us 3, obviously, because we have 3. And now the upper bound on 4 gave us again 5. and the upper bound on 3 gives us 5 again. So there is a slight difference in how they behave. The lower bound gives us what we asked if it exists, and gives us the next bigger entry if it doesn't, while the upper bound function always gives us the next key bigger than what we asked for, even if the key we asked for exists already. Where this is useful is a bit of an exotic use case. At least I use it always in more exotic use cases, but it is quite a nice thing to be able to do it. If you are interested, we can maybe during the next lecture take a look into it. I would need to prepare a demonstration of how this can be used. I only have it in a rather big project, but it is something which I also used a few times in different places where I don't explicitly remember the details, where that also came in very handy. So it's good to keep in the back of your head that you can this way kind of get things from your map. And also yeah, and let's continue with this map explanation. So as you have noticed, the map is sorted. So if we click on it, we see it's really sorted like numerically by the size of the value. So what is needed if you want to use a value or a class of your own, for example, as a key. Maybe you create the class which represents an IP address. That would be a reasonable use case. Then what you would do is you would have your class. If you want to use it in a map, you would need to edit the less than operator, so that the system can establish an order between different elements. It doesn't even require a comparison operator, because if you have just a less than operator, you can already construct any other operation from it, because you can check if A is less than B or is B less than A. Then you already know, for example, if they are the same. So if both are false, then they are the same. If one is false, the other is not, then they are not, and things like that. So you only need one operator, and that's it. And then you can use your class as a key in any sort of map, which is quite useful. What else would be worth mentioning about maps? I think at this point this is it. There are some. If you can check the documentation on. I'll put a link into the